This conference will now be recorded.
Okay. Hey, everyone. Happy Friday and everything. So today our rolling agenda is Robert at Analog X. So I want to spend some time on the agenda and see. We have nothing structured scheduled on the 14th or the 21st. If anyone's interested in speaking on either of these dates, now's a good time to pipe up. On the 28th, it's what I've taken to calling open mic night for Chiplet business model. So far we have DJ, I think, right. We have this many there's literally no constraints on, I'm happy to give everyone who wants to offer an opinion some time. DJ has some thoughts on maybe structuring the discussion. DJ, you online?
Yes, I'm online, Bapi.
Yeah.
So I think what we should do, if all of you who are interested in the Chiplet business model, if you could share one or two lines in terms of the areas which we as a group should be addressing in this work stream, please send it to me via email. And the way we plan to do this on 28th is, obviously it's going to be open mic, but we want to quickly kind of converge on what are the few things which this business model work stream should focus on. So this is our opportunity to define it and then take it forward. So that's where we want to head very quickly. So to the extent possible, if you can share your thoughts via email, that would be helpful for us to kind of guide the structure conversation on 28th itself. And then we will go through, quick thoughts on how should we run this work stream and such. So even if you have those ideas, please share it via email so that we are very efficient on 28th with the open mic. So those are my thoughts.
Do you want us to send you the thoughts ahead and then
yes,
have
please.
open mic?
Yes, please. Both, yeah. Send the thoughts ahead. Let it be free flowing. I will do my best to collate everything into a cohesive, a slide or something like that to kind of structure the themes which have emerged. So that way everything gets captured, and then we can have a discussion. But it would be nice if people already have the thoughts. Please do share via email, and Bapi, you can type my email there as well so that people have that. Thank you.
So JANID. Okay, I got it.
Wait, Bill, are you interested in? Are you interested as well?
Either myself or Bill Bottoms, one of us will take this on.
Okay. So now I have a question for DJ. We're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be tough to get through that in one session. Do you want to move up to the 21st as well, or is that too soon, DJ?
No, so this is why I'm requesting thoughts from everyone on what they think should be, focused on, and that helps us organize on 28th, right? So
okay, so let me do this. Anybody who can send slides by the 14th. That's about a week, right? This is not a deep thought exercise, or maybe if you want to make it a deep thought exercise, of course, go ahead. But maybe by the 14th, should we say, for a first draft?
yes.
If there's enough people ready, we can see whether we can move something up to the 21st, so that everybody has a few minutes to talk.
Right, and I want to keep this lightweight for everyone in the sense, if you can send slides, that's awesome, fantastic. I would love it. But let's say if you're very busy and you want to write a long free-flowing email on just dumping your thought process, go ahead and do that as well. And I will do my level best to organize the themes emerging. So either way works. The important thing is, please, we want to hear your thoughts. Otherwise, it just becomes, one person monotonous speaking, right? Which is not very productive for the community. So that's where I think every one of us need to kind of bring our thought process into the discussion to make it an effective work stream. By the way, does everybody agree with this approach? I even want to ask this, and really, I would like to hear from Sam, Marshall, Elko, Ali, Tawfiq, Alan, Rohit, Suresh, and Bill right now. That does this approach make sense? This is where I'm trying to bring an engagement. So each of you, please take 10, 15 seconds to kind of express, does this approach make sense, or if you have a way to improve it? Let's start with Sam. Sam, talk.
Approach takes a lot of good sense, and if it doesn't work, it's all your fault.
Okay, how about Marshall?
Marshall, I don't see Marshall either. I'm looking at the list of people today.
Okay, Marshall is not there. Let's keep going down. Elko,
Suresh,
how about Elko?
Suresh or Elko? Today? Oh, Elko's here. All right.
I'm here. My question is, business model, there's a whole ecosystem, right? From whose perspective, or what is there some nuance to this, or is just collectively, depending on who you are in the ecosystem, what do you want to see, or stuff like that?
Absolutely, Elko. There is no nuance to this. Business model has to include everyone. It cannot be single-sided, right? So
Yeah.
Simplistically, the business model should include all the folks who are producing technology and all the folks who are consuming technology and everything in between. So there is no nuance to it, Elko. Everybody should bring their perspective and be there to represent your company's interest. That's fine.
Yeah, this was Suresh.
Okay. Hi, Suresh. So yeah, does that answer your question, Suresh?
Yeah, absolutely.
Okay. How about Ali? Ali, any thoughts?
Today is it's a weird day, man. Elko's here. Elko?
Yeah, I'm here. I mean, my understanding is, I like DJ's idea. I think the idea is, let's table what everyone sees as the issues, concerns, potential items that need to be addressed in the business model discussion. And I think once we, even though there's 10 people, once we collect this, we'll probably down select this a bit and find a lot of commonality. I think that's where you're headed with this, right, DJ?
Absolutely, exactly. That's where I'm headed at. We don't want to claim that we think there is an answer which we kind of want to work towards. We want to collect ideas and come up with an answer which works for everyone. How about Tawfiq? Tawfiq, any thoughts? Do you agree with this approach?
I do, and I'm definitely,
Okay. Yeah. Alan?
Yep, I fully support it. Sounds like a great way to do it.
Awesome, thank you. How about Rohit?
Yeah, this is a good idea. So I'm thinking it's good because you have a whole ecosystem here, producer as well as consumer. So I think me and Tawfiq and perhaps you will come with the end user perspective as to what we want. And then I see that there are a lot of producers of these chiplets also in this. So that'll be good. Yep, agree.
Yeah, exactly. Thank you, Rohit. So I think we have everyone's thoughts here. Thank you, everyone, for sharing. And I'm looking forward to kind of helping all of us kind of move forward on this business model side of things.
Yep. So send your thoughts to DJ by the 14th if you can. Like as he says, it doesn't have to be super structured. The idea is to sort of get as much as we can.
So by the way, sorry.
No, go ahead, please.
Yeah. So DJ, like I think there used to be a business working group before. Is there anything which was shared? I'm sorry, I didn't follow through all of those as before. But was there anything you can send us participants on this August 28th, the background as to what was discussed there?
I can. Sam, do you have any stuff from prior discussions which we can you can point to, and then I'm happy to send, or you can send, Sam.
Sam isn't online, but basically we've had one business session at virtually every workshop, Rohit. So if you go to the wiki, there's enough, there should be enough to sort of get started.
Okay, okay, fine. I'll look at that.
Okay. All right. Then one last thing. Anybody has any thoughts on speakers? We're not thinking about TSMC or quality and reliability. Anybody have any thoughts anywhere? I pinged Dave Kellett about AIB again. He should hopefully get back to me this coming week. So this one's gone. So any other speakers anyone has in mind? Okay. In that case, let's see. Our topic today is Robert at AnalogX, and I think, Robert, I'm going to stop sharing, so you should be able to. He's going to present his company's die-to-die interface. Robert?
Okay, yeah, can you hear me?
Yeah.
Okay, great. Let me see how this GoToMeeting works. Can everyone see the presentation in full screen mode?
Yes.
Okay, I'll minimize this. Okay, there we go. All right, so I'm going to get started. Thanks for everyone to join us today in introducing AnalogX, our company that focuses on interconnecting chiplets and chips. Okay, so in terms of chip design, on the one side, it's becoming simpler due to an existing ecosystem, maturity of how to do chips over the past several decades, and with various different engineers from all sorts of different disciplines to be or have designed very complex systems. On the other side, chip designs have becoming even more complex with packed features, aggregation of various subsystems into a single chip. On the interface IP alone, package design choices, which protocols to use, and how to integrate and test the I/O, and its overall power, performance, area, and cost all play significant factors. Due to a slowdown in Moore's law but more demanding processing power, there's a shift that's happening in the interface IP. Traditionally, we would have a multi-protocol service and a service that will work with all interfaces. But that has a power penalty as well as latency overhead. But it satisfies all the needs. Due to domain-specific designs, new applications are emerging where consideration of power, cost, area, and performance are the key driving metrics. Here, that's why AX is born. We interconnect with the real world, which is analog. So A stands for analog, Processing is done in digital, and that's X. For chiplets, there are a number of questions to be answered before even a choice is made. And the questions addressed in this presentation are as follows. What type of packages to choose from here? How to design system to pack the most number of transistors in a single cluster, and how to maintain that scalability by using industry standard protocols. What are the ecosystem and what has been created, and how to leverage that to grow the chiplet community? What are some of the testings that can be done ahead of time to verify the IP, as well as how it can be verified in a system? Chiplet needs to be in different technology nodes and all sorts of technology nodes, different foundries. How do we realize that? How is it, it is very important to make sure that we make them work together, but how do we do that? And what is the approach? So package technologies have evolved and advanced quite significantly over the past few years. Here I've listed the main ones, and by no means they're the only ones, but these are the ones that's being discussed with various interconnect IOs in the ODSA. So we have the EMIC technology, and then there's the AIB interconnect. For interposer-based package design, there is HBM and OpenHBI. For info WLP, there's limping count introduced by TSMC. And lastly, there's organic substrate with various industry standard solution here. Now, as each packaging technology is different, each will have its addressable market. And not only that, for each of the package, there is a suitable IO for that specific package. Another way of seeing it is that the IO design is actually takes advantage of the each packaging technologies here. The IPs that we design works with all packaging types because it's in the silicon, it's not dependent on the package, but it's able to leverage more of the lowest cost organic MCM substrate and standardization of IP solutions that's already in existence. As IC designs have evolved over the past several decades, industry actually has kept pace with various different interface standards. And one such organization, OIS, that has been discussed in this forum previously with other sets of interface IPs, has been heavily leveraged, where its actually footprint is everywhere, in Ethernet. A lot of other SerDes solutions also base their solutions on OIF, and hence traditionally there was the multi-protocol SerDes. In addition to that, its specification has been adopted by industry with various vendors and users. So it's created a huge community in terms of the interface IPs. In the past several years, OIF has also finalized shorter reach SerDes for die-to-die operations. Here, USR is for die-to-die, ultra-short reach. XSR can be used for both die-to-die and die-to-chip with a growing number of IP providers. The goal of these standards is really to provide a power-optimized interconnect solution for each usage application. And the AX interconnect solution is based on OIF CEI's specification. Now, continuing with the die-to-die discussion here, there are a number of physical limitations for both the die-to-die reticle size limit and the package size limit. For die reticle, it is inversely proportional to yield. As foundry technology moves towards finer and finer nodes, the solution is to enable die-to-die interconnect for both yield and density, or achieve effectively upgraded density. That's also the same and being true for the package size. it cannot be the size of an entire PCB for the package size. Various physical limits come into play when package reaches its overall X and Y size limit. As a result, to achieve maximal transistor density in a cluster of PCB for the area, both die-to-die and chip-to-chip solutions needs to be considered. And when such considerations are considered, it looks something like this. When we realize a system where there are chiplets that perform specific functions, such as optical engine in silicon photonics or AR SerDes. However, to connect to the rest of the system and to have enable greater density, a power efficient solution can be realized using die-to-die interconnect and chip-to-chip interconnect. Because the pipe interface has been widely recognized and used by many different interface standards and protocols, it can be used for protocols such as PCIe, CXL, CCIX. For other applications where lower latency is actually required, a general SerDes type of interface can be used. And pipe interface also supports a SerDes interface. This is for the various different SerDes interfaces, additional protocols such as interlaken can be used for HPC applications. In parallel, in terms of development effort, there's also an ODSA agenda for the pipe adapter. Its aim is to be compatible to the existing pipe interface, but without the heavy burden of all necessary features that's required in PCIe. Bapi, myself, and Mike are the main driving effort on this, and we hope to finalize its a recommendation in a white paper in the next several weeks. So once the interface interconnect IP is available, it's also important to consider how to test it and what can be tested. This is where a standardized based specification is very useful because it's already agreed upon by the industry with a great support behind it. It defines the interface specification, compliance without ambiguity, uses industry standards set of equipment, components, and know-how with a great ecosystem for such support. And the cost for these testing infrastructure is also very reasonable. So what I've shown here is that it's possible to have the transmitter testing by hooking up to a high-end scope with industry standard components, as well as perform receiver testing and receiver jitter tolerance testing by allowing a jailbird to transmit a specific data pattern and look at the compared to the received outputs.
So back on that previous slide. So how does that test equipment plug in? Does it actually go onto the site of the silicon as a chiplet?
I'll address that a little bit later because for organic type of substrate, if your target insertion loss is anywhere exceeding 6 dB, or you can do it with 4 dB as well. You can design a test chip platform where if your package only takes away 1 to 2 dB of your margin and connect it to a high-speed SMA connector with a very short cable, you can ensure that entire loss is kept within 2 to 3 dB. And because of that, you can actually hook it up to a scope or have a jailbird hooked up to the receiver.
Okay, thanks.
So for the analog X interconnect focus, we don't just look at power and the cost of implementation, even though low power is a key and one of the things that we talk about all the time. area, latency are all very important from an application performance point of view. But compatibility and scalability is also paramount by leveraging existing ecosystem and the usage of this entire solution into a chiplet solution for all the reasons and the questions stated in the previous slides. Okay. So for the Analog-X IP portfolio for various interconnects, we have divided them into 3 different classes. Just like the OIF solution, if you look at their specification, there are 5 classes of different IPs. Here we have 3 different classes. And as everyone in the audience already also knows that in order to drive longer distance, greater power is required. So when we compare something that's driving several millimeters to several inches or whatever, greater power has to be spent. So for the most power efficient interface, which is the die-to-die interface, the distance is usually measured in the tenths of a millimeter. So this particular IP can drive up to 6 to 8 dB of loss, and it's less than a picojoules per bit. This particular distance allows the driving distance within an organic substrate of 70 millimeter, though 70 millimeter likely is not fully required. But as in the previous slide, the reason that a 6 to 8 dB of metric is good to aim is mainly also for testability. In the chip-to-chip application, this distance is usually extended to tenths of inches. And currently our IP, depending on which technology that we're referring to, it's less than 2 picojoules per bit. For advanced processing technology like 7 nanometer, it's around 1.5 picojoules per bit. The multi-protocol service comes in at a very respectable less than 3 picojoules per bit, and it has a much better reach capability. As a result, as everyone can see, the overall power and driving capability is directly correlated. And when we compare different PHYs and different solutions, there's that driving distance as well as the cost to be considered.
Robert, on the previous slide, the chip-to-chip connectivity is on a PCB?
Yes.
Okay. And so is the multi-protocol.
Yes. So what I've shown here, maybe I should have spent a bit more time. So we have the die-to-die in the red ink with 2 silicon dies on top with bumps hooked up to a substrate. That substrate with a much larger balls is hooked onto a PCB platform at the very bottom. So you can see that through traces for the MCM type of organic substrate traces, and the traces for the chip-to-chip goes through the not only the substrate but also the PCB board. In the multi-protocol, usually in these cases, you want to actually have a connector in between the 2 PCB board system. That's why the multi-protocol other side of the system is to vertically to represent that connector.
Thank you.
And sorry, Robert, I have another question on that front. This is and you said this is a OIF version 3 standard.
Yes, it's so OIF has several different standards. They have OIF USR for NRZ, OIF
but this
XSR for the NRZ, and there's also a 112 gig PAN version. But what I'm saying here is that our chip-to-chip and die-to-die solution is based on the OIF. So I think the focus for this discussion is for die-to-die and chip-to-chip. The multi-protocol and the PCIe needs to be other protocol compliant in terms of electrical interface.
Okay, thanks.
Okay. So currently, the AXIO technologies is already available across multiple different foundries and across multiple different technology nodes. And this is the power, I think, of an interconnect solution that's based on a standard through very ease of porting, high configurability, and known testing methodology. Although not everyone is currently demonstrating our power and area capability, but present solution can work with various different chiplets with many IP vendors. Thus, it's very realistic and possible to extend the availability to much greater number of foundries and technology nodes based on cost-effective packaging solutions. And by combining all of the available foundries, so these are what we currently have, but if you will combine the entire ecosystem together, now you have a true chiplet ecosystem solution where a system is able to use technologies, regardless of which foundry it comes from. There's no restriction on specific bump pitch or bump size or configuration. Becomes very powerful, economical, and feasible to realizing today's solution. Okay, so here I'm going to come back and address the test for using industry standard equipment a bit more, and I'm discussing the reference to some of the channel insertion loss and using organic MCM channels as an example. The example can be extended to other packaging as well, but the analysis typically done at OIF, Ethernet, and PCIe is a bit more detailed than what I'm showing here. Here, what I'm representing is a channel length in terms of millimeter for an MCM type of package. And the actual insertion loss really depends on the material the package uses, right? You can use a lower loss material with by spending a bit more money. But by no means that these numbers are set in stones due to the various material to be used. Roughly, however, one can equate that it's possible to achieve a metric of approximately 0.1 dB per millimeter, give or take with some flexibility. Or you can equate that 1 dB equals to about 10 millimeter of driving capability. So as a result, an interconnect solution that it needs to drive at least a few dB in order to connect the various dies together, because most likely they will be placed 20, 30 millimeters apart. But if you just increase that driving capability by a little bit, which allows each of the direction to drive 3 dB, it is possible now to escape the signal from the MCM package onto the PCB and then use the standard equipment to do the testing. So what I mean here is that if you have a test chip and various different IP providers have that test chip configuration, including Synopsys, Cadence, we have test chips as well. It's about 1 to 1.5 dB to escape from your die to the ball side of the package, and from that side, it's another 1 to 1.5 dB to connect to the instrument. So 3 dB becomes more than sufficient to allow you to test all the silicon and the dies in that solution space. Then what is shown here is that now this is a diagram from an existing public specification from OIF. They're showing a chip connecting to an optical engine, but the reason I'm showing that is they define the test points of what to connect and what to test. And this testing methodology has evolved from 2.5 gigabits per second all the way to over 100 gigabits per second, and it's very well established over the past 20 years. We can test for electrical signal compliance and use existing methodology. In addition to that, Whereas the building self-test and the building self-diagnostics can also be available, but here this is where it's you know, a little bit different from all major providers. So we're going to show the version that we currently have for die-to-die and die-to-chip type of interconnect. So the AX App Manager interface here is used to demonstrate internal silicon capabilities for diagnostic and testing. Starting with the eye diagram, that's what generally everyone likes with the eye diagram. On the top right corner, it shows that what the receiver sees looks something like this. And rotating counterclockwise to the upper left corner, the app is also able to plot both the eye width bathtub as well as the eye height bathtub to beyond 1e to -12. And this is very important because it can provide statistical information for extrapolation to calculate much lower bit error rate targets to 1e to -17, 1e to -22. Lastly, just like a bird, a realistic real-time best error counter as well as a very PRBS selectable pattern can be used to do receiver, transmitter to receiver testing for both die-to-die applications. Patterns are already programmed into the IP's internal database that includes clock pattern, PRBS 7, 9, 11, 13, 23, PRBS 31. That's really user configurable and can be added with additional patterns. A user can also put in a user programmable pattern there as well. Now, I do want to spend a couple minutes to discuss some differences in terms of you know, the interposer or EMIB type of solutions versus a traditional high-speed type of signaling here. And what we wish to address here is the discussion of low bit rate and need for, you know, FEC or not. Now, in a typical organic substrate MCM channel, as I indicated previously, a 20 to 30 millimeter of driving distance is usually sufficient. And what is shown here is a 3 dB channel in terms of simulation. Based on extrapolation of both the eye height, where you look at the SNR, and the eye width, you look at the jitter margin, there's a significant margin to ensure error-free operation. Of course, in the protocol, one can always add in additional FET or even ECC to enhance the overall resulting system's error rate. But because these channels are so short, it's very realistic and possible to achieve a very low bit error rate. It's just that within our lifetime, typically within one channel, you won't be able to test it to 1e to -22. So, what's shown here is a single-ended die here for a 3 dB channel. As you can see, it's you know, it has a very good eye width as well as jitter margin. When you transmitting single-ended, you loses half the amplitude, but all the signaling here is terminated. Okay. So I'm not going to, you know, dive into PPA too much here. Our die-to-die and chip-to-chip IP solution is very competitive. You're looking at the B chip front of 1 to 2 terabits per second per millimeter. Power is 1 picojoules per bit, and the area of the entire IP is really bump limited because it's with the typical organic substrate, the bumping technology right now is about 130 micrometer bump pitch. In ODSA, and especially with BAPI's effort, currently various different file providers are pulling together and publishing, I think will be a huge table of various different metrics. And there's going to be a detail to be published by ODSA. I believe we're targeting the hot interconnect paper that's coming up pretty soon. So any readers can dive into that to look at the specific metrics. But I've generally outlined the key metrics that most of the people care in this slide. Okay, and yeah, that's the end of the presentation. Are there any questions?
A very good presentation, Robert. Alan here. So if I got the general gist of your presentation right, it sounds like you're restricting everything around the testability rather than the capability. If I got that correct?
I believe that's incorrect. I'm saying that testability is a component of an interface IP, but I believe compatibility and interoperability is also paramount when folks are pushing for specific solutions. And there are existing standardized solutions already available, and we are a part of that. And in that electrical specification, it outlines how to do the specific design to meet the electrical specification, how the various different providers of that specification can come together to be able to interop, and it defines what the criteria is to meet those electrical specification via a testing methodology.
Right. Okay. Yeah. So the so you've expanded on, I guess, my point. But yeah, the interoperability and against industry standards is what it's all about. But it sounds like you could. It's very, you have to reach 6 to 8 dB. Sorry. Yeah, 6 to 8 dB. I think you said, so that you can build in the traditional test equipment. What I'm hearing is we need a revolution in test equipment, because the test equipment is limiting. Instead of being a big scope on a bench with SMA and cables, it should be a piece of silicon that goes on the standard test site that is benchmarked by IEEE as the gold standard for measuring. And then you could, it sounds like the test equipment is causing you to restrict the capability of the channel, which seems aspect using my
yeah. So Alan, I would absolutely disagree with that, because I think testability is becoming more or less a nice to have. If you look at the internal test, test capability and the best function of the solution that we have, there's no means that you have to design it to 6 to 8 dB. We just designed it to make it easier. But if you look at the testing capability here, where internal eye diagrams can be measured, Bathtub can be measured in terms of to look at jitter for extrapolations. Eye height can be measured also to 1e to the negative 12 to look at your extrapolation of SMR. And you can program different PRBS selectable pattern from anywhere from PRBS 7 to PRBS 31, or you can program in more, pessimistic data patterns, and have real-time building self-test.
So I actually, I think we're in complete agreement, actually. Yeah, the capability of all the silicon these days, it has to, by definition, have all these features that you just rolled out. And so but I think the interoperability point that you made is you need this independent body of some sort to say, yes, everybody's channel is compliant to the spec, and therefore everybody's channel should be able to speak to each other. What I'm thinking is, in fact, what you've just described there is, it sounds like you've got a better piece of test equipment in your silicon than Tektronix or LaCroix or Roden Schwartz or whoever. So why do we have to do breakouts and SMA cables to old-fashioned test equipment? What do we do? What can we do to make the testability built into this silicon actually give us the interoperability tick box, so to speak, to say, yes, this complies to the spec? So we almost want IEEE to be saying your built-in functionality of testing functionality and calibration inside your silicon needs to follow these features so that you can get the badge of honor that you are compliant, rather than this breaking out to old-fashioned test equipment.
Oh, that point I very much is in agreement, and I believe that there needs to be both the advancement in terms of test equipment, as well as more so in the internal testing capabilities here. So what I'm illustrating here is that if one wants to use a standardized equipment, they can do so, or if one relies on the silicon and its internal capability, they can do so as well. There's no restriction as far as the IP or interoperability is concerned, but I can't. Yeah, someone may wish to use one method versus another.
I don't think our performance should be limited by the test equipment. I mean, obviously we need to make it testable, but if traditional test equipment is limiting performance, then we need to find a new way to test. So we don't give up performance just because of the test equipment. So that's my point. All right, thanks. Very, very good presentation. Very educational. Much appreciated.
Thanks, Robert. Any other questions for Robert? Oh, I for sure thought Suresh would have one, but anyway.
All I was going to say is the in-die virtualize has been around, so that methodology exists. It is absolutely critical as we move to die-to-die interfaces. That's all
Has it been taken to the standards bodies? Is some way to say you comply?
That I don't think so, but different vendors have had this capability to be able to look at virtualize and come up with a metric for how good the channel is.
Yeah, understand that. I think we just need to close the loop and get rid of the old test equipment. That's my view.
Okay, on that bright note, let's see. Is there anybody? We had a bunch of leaves. Anybody who wants to introduce themselves new to this audience? Anybody who's been around for a while wants to introduce themselves? Anyone? Okay. Then I'm going to go to the agenda for the engineering workshop. Here's what it's shaping up to be so far. There's a list of, there's a pool of topics. Is Archana still on? Nope. There's a pool of topics. I think we'll have to cut it down to a day. So we have 5 proposals for panels. One is memory in chiplets. If you can get hold of speakers. The second is known good die. Thirds are, so these two are standby favorites, 14 and 15. We've had known good die in 5 panels. Then if this business effort, if this open mic night leads to some sustained thinking, structured thinking, then we do a panel on the business work stream. And finally, one of the other ideas is that we should start talking about management inside multi-chiplet packages. So we're likely to do a panel with the OCP Hardware Management Task Force or the project, do a panel on management in chiplets. Those are 5. This is what we have in terms of lightning talks so far. So we've got about 9 companies. Maybe sort of give everybody or take a couple of minutes away depending on demand and how we fit into the schedule. And I think, wait, Anu wanted co-packaged optics, right? I'll make this
Just a suggestion.
Yeah, we'll throw that in, and we need to find somebody, but
That's volunteer Shab.
that's true. Okay.
Hey, Boppy, question for the lightning talks. Are you envisioning these to be live or pre-recorded and then available for Q&A?
I think the entire conference is going for pre-recorded.
Okay.
Much like, I would like the panels to be live, but it's probably impossible to pull off if you have hardware glitches, etc. So we might do our thing where we record them on one of our Friday meetings so that we have some Q&A. And if you want, we can do that for this too. Then, you know, for each of these talks, we can record them on the Friday meeting so that each of them has a live audience and they can snip off the 20 minutes. Shab, you want to volunteer for this?
Sure. I think this is exactly what we are doing in Ireland.
Okay. All right. Anybody have any other suggestions for topics? We'll have to cull this down in some fashion, but this is where we are, and as usual, we're sort of oversubscribed. And is it 9 o'clock already? Okay, so then in terms of opens, I think we covered this panel versus 30. So Alan, we're sort of 80%. Every time I think we're 90%, which turns out it's more time. So we're sort of 80% of the way through like a huge crossfire comparison. I hope to publish this soon. Then I did a talk at DAC and they've given me the okay to post the video. So I'll post this video. I'll hopefully have Michael put this video up on the wiki along with the slides for the DAC talk.
Thanks.
Then in terms of progress, we're sort of heading towards we've got like good progress on the crossfire comparison. We're trying to get a Bose spec in place sooner rather than later. Arthur at Cadence has got really good progress on a link layer. So if you have any interest in a link layer, want to contribute, participate in spec, now's a good time to intercept it. As Robert said, Robert and Michael and I are trying to go for the knock this off as well. POC, JP, do you want to say anything, or are you still with us? We lost JP. Okay. Anything else? If not, going once. All right. Everybody have a good weekend. Yep.
Sorry, this is JP. I was in mute. So regarding the POC, we made very good progress. All the board design has been completed, and we'll be fabbing out probably in a week or so. So all the checks have been in place, and so we are good to go.
Okay.
And we are targeting a demo by November this year, during the November workshop for a demo.
Fantastic. On that positive note, have a good weekend, everyone. Thank you all.
Thanks, Poppy.
Thanks.
Thanks. Bye.